Okay, so I accidentally exited out of my recording, and so I'm gonna just talk through this problem. This was a question about Aaron, and Aaron was borrowing money for a snowmobile. The original price of the snowmobile was $17,000. That was how much he was borrowing over an 8-year time span. We knew that the total amount that he was going to have to pay after 8 years was $24,480, but we didn't know the interest rate. That was what we were trying to calculate. Because it said it was a simple interest, I was using the simple interest formula, I equals PERT, where I is the interest incurred, P is the principal, that's the original amount that you borrowed, R is the rate, which we didn't know in this case, and T is the time. Now, in this formula, R being the rate, if you're using a calculator, which most people do, calculators only like decimals, they don't like percents. So we have to change this to a decimal to use it in the formula, or we have to change it back to a percent at the end. And T is time in years. This formula is only set up where T can be years. Plugging in the information we know, we knew that the principal was $17,000. We did not know the interest rate. That's what we were trying to find. And we knew the time, being 8 years, was the time. I did have to take an extra step here. I knew the total that he ended up paying. I knew the amount he borrowed. The amount of interest then, just the interest amount, was $7,480, and I got that by subtracting. The total he paid minus the amount he borrowed, that gave me the interest incurred. So that was the extra money that he had to pay, the interest. Then I combined like terms. I divided to solve for R and got this decimal, 55 thousandths. But because percents are out of 100, I multiplied that times 100 to get 5.5% interest rate. Now I'm going to try and show the next problem. Ooh, I think I might be able to without stopping my video. So the next problem is right below. It says to buy a car, Jessica borrowed $18,000 for 5 years at an annual simple interest rate. So again, simple interest, I equals PERT. I'll make the video bigger here in a second too. I'm going to write down some information. She borrowed $18,000, so that is my principal. For 5 years, that is my time at a simple interest rate of 4.5%. Now I'm going to go ahead, and I know that screen is a little small, but you should be able to see it. 4.5%, percents are out of 100, so if I divide that by 100, as a decimal, 4.5% is 45 thousandths, 0.045 as a decimal. You can kind of see that filling in there a little bit. Okay. How much interest will she pay if she pays an entire loan off at the end of the 5th year? Okay. Zooming in this problem they gave us all the information we needed to use this formula. They gave us the principal, the original amount borrowed, the rate, which is hard to see, but 0.045, and the time, 5 years. So if I plug all that into my handy dandy calculator, 18,000 times, too many zeros, times 4.5% times 5, I get $4,050 as my interest. That's not the new total. The new total, you'd have to add that on to the original amount you borrowed. If you borrow $18,000 and you only pay $4,000, the bank won't be happy. So you got to pay your $18,000 plus the extra. And that's how this formula works, is it tells you the extra amount that you have to pay. All right, again, I'm going to try to do this. Last interest question I'm going to do in this video. Karen put $600 into an account for school expenses. The account earns 3% interest compounded monthly. Compound interest is this formula here. So I'm going to write down some of this information. and then I'll make it bigger and talk through it. The interest rate was 3%, and it was compounded monthly for 5 years. Okay. Here we go. This is the compound interest formula. I'm not going to go into where all these numbers come from, why it works, and all that. That we will do that during class, but I'm not going to do it here. P is still the principal. It's still the starting amount. 1 is because you get to keep 100% of your money, plus some interest rate. Now the reason it's R divided by N is because it's every month. So we are going to take whatever our rate is for the year, our annual interest rate, APR, annual percentage rate, and we're going to divide that into however many times we're compounding it. Most of the time it's monthly. Sometimes it's quarterly, which would be out of 4. Sometimes it's monthly out of 12. Sometimes it's annually, so it'd just be over 1 once a year. Sometimes it's compounded semi-annually, which is out of 2. So N would be 2 if it was semi-annually. In this case, it's monthly, which is 12. There are 12 months in a year. Time is 5 years. Again, T in this formula is in years. All right, I'm going to fill in the blanks then. I know that the principal is 600. I'm not going to put the decimals, 0.00, but they're there. 1 plus the rate. Again, I'm going to change my percentage rate into a decimal, 300ths, because percents are out of 100. N, in this case, is 12, because it was compounded monthly. N is 12, because it's compounded monthly. And T is 5. There are a couple of ways you can type this into your calculator. If you want to type it all at once, you do need to be careful of this exponent. You could put parentheses around the exponent if you wanted. What I'm going to do is I'm going to do 12 times 5. I know that if you're 5 feet tall, 12 times 5 is 60, or 60 inches tall. So what I'm going to type in the calculator is I'm going to type all this just the way it looks, except I'm going to put 60 for 12 times 6. So I'm going to put to the power of 60. That's going to give me $696.97. We do need to round to the nearest cent. In this case, there was nothing in the thousandths place to round up here or keep it the same, so it's just 97 cents, but you would always stop at the penny when you're talking about money. And that would be the answer. Hopefully that helps with how to set that up. Looks like you were not too far off. I don't know if your decimal was a little different or how you did that, but that's how you set that problem up.